Let's try out the new Monport 70-watt Mega CO2 desktop laser engraver with LightBurn. Hey peeps, today we're going to show you how to connect, set up, and use the laser's integrated camera with LightBurn. We're also going to be utilizing and demonstrating other helpful features within this software. But if you want to see how we set up this laser and an overview of the free software that comes with this machine, we have another video covering that. A huge thank you to Monport for sending us this powerful laser engraver. If you're interested in this laser or any Monport machine, you can use our discount code Anonymous10 for 10% off. We'll have links, details, and more discounts in the description.
So out of the box, it comes with supplementary instructions, and this is where you can find some LightBurn settings that are important for setting up in LightBurn. In particular, obviously you have your length and width, but the baud rate here looks to be at 1,000,000. So we're gonna have to make sure we set the baud rate so that our computer can talk to the motherboard of the machine. I'm gonna go ahead and open up LightBurn. It pops up with configuring a device. Unfortunately, the Mega, we can't just use this Find My Laser feature. It won't pick it up. So we're gonna have to manually set up our laser. So to do that, in accordance with our supplementary instructions, we're gonna go ahead and create manually. And then we're gonna scroll down to GRBL. We're gonna select serial USB. And now we need to enter our workspace. Now we know the machine homes in the rear left corner. So we're gonna go ahead and set that, and then we're gonna have it auto home at startup. And that's it. We're gonna go ahead and hit finish. Okay, so with that change, it updates our workspace. Now we need to go ahead and connect the machine and turn it on. So we're gonna go ahead and use the cable that came with the machine and just plug it into our computer. And then we're gonna turn on the machine. So our computer picked up the device. We're going to click on COM3. And you can see right now our machine is not properly connected. We have a lot of special characters in there that's not right. And that's because we need to set our baud rate for the machine. So we're going to go ahead and click on our device settings icon here. And then we're going to change our baud rate to 1,000,000. Click OK. So I did have to disconnect from the current USB connection and then reconnect, and then now you can see we are actually connected to the machine. So if I wanted to, I could actually move the laser head around with our keys here. All right, so we're connected to LightBurn. So now that we're connected to LightBurn, let's try and connect to this camera, but you can see there's no port for our camera connection, and that's because the camera is integrated into the motherboard in order to kind of display over Wi-Fi. But there's a hack we can do to connect our camera to LightBurn. So let's do that. First, we're going to turn the machine off. So over here on the left side of the machine, underneath this panel is our motherboard. Now I've already unscrewed all of the screws here, but you can see right up here there are two USB connections. So this port right here you can see is hot glued in place. This is our serial port that runs along the machine to the other side and where you plug your computer in. And then the one underneath it, there's another USB. That's the camera that plugs directly into this motherboard that ends up going over Wi-Fi that you can connect to the MDH software. So the hack here is we could unplug this USB and plug this directly into our computer, and we will have a camera. Now, because this is on this side, but the serial port to connect the machine to USB is on the way other side, we're gonna end up just using another cable to plug in here to our computer. So this is our camera USB, and we can plug this straight into our computer. This one wasn't really hot glued in place. It's mainly this one here. Oh, yeah, it's not bad at all. So this is where this line here just plugs all the way over to the other side there. to keep our computer plugged into one side. We don't have to like plug a wire all the way to the other side because that's all this wire does. We can just disconnect this one and use another USB cable to plug directly to our computer. So we'll have our camera and then we'll have the motherboard plugged into our computer. We've already tried this using this cable, except backwards. Plug this side into the motherboard and this USB-C into our computer, but we could not get it to connect that way. The only way we could get it to connect directly to the motherboard is going from a USB-A to USB-A connection. So I have a USB-A to USB-A connection from another machine, and all we need to do is plug in one side to the machine and one side to the computer. And we can plug in our camera. So we got everything hooked up right. We're moving the machine around. So we are connected, and now obviously we wouldn't want to leave it like this. If this was actually going to be how we were going to run this machine long term, I could just cut a few holes into this panel and run the wires out of those holes, or get a USB data connection that I can mount here and then connect wires to that connection. But this is obviously just a short-term test solution, so don't judge us too hard on us just leaving this stuff out here. Yeah, that was pretty simple. So now we're over here, we're bypassing the existing cable that connects it to the other side. And let's see our camera, see if we got a feed on that. Yep, it looks like we have our camera and we can see it is there. So now we can configure this camera. We can now actually use the camera function in LightBurn. So let's see how easy this is. We're gonna go ahead and go to Laser Tools and Calibrate Camera Lens. Now I can see here that this doesn't appear to be a fisheye lens because we have some straight lines along the edges. So I'm going to go ahead and configure it as a standard lens. We're going to do a full calibration, and we have this calibration pattern already printed out. I'm going to click next. So now let's get the background clean. We get better results without the honeycomb underneath. So we're going to get a white panel to put underneath there just to kind of make it more uniform. This is a massive workspace. So we're going to put in our circle design, and the first place is right in the middle. I'm going to uncheck this honey bed, and we're going to go ahead and click capture and see what kind of results we can get. Okay, I'm going to hit next. Now it wants me to place it at the front of the machine. Okay, next. Then you go to the left side of the machine. Now a tip here, if you're having problems, we have found that lighting is really the issue that can solve a lot of your problems, whether that be blocking out some of the light coming in or adding light to it as necessary. Fortunately, we're pretty good here, and we're getting some good results without having to adjust anything. But if you are having issues with the LightBurn camera calibration, check your lighting. Move the laser head out of the way. And that's it. You can hit finish. And then now let's put in a piece of scrap cardboard to do our alignment. Before we do the alignment test, because we cannot get autofocus to work because autofocus works based off of the LiDAR, we have to manually move this laser head down. So we can do that using the Z move feature to try to get us close to focus, but it's not going to be perfect. So let's just get this down so it's a little bit more focused as much as we can, and then we'll run the alignment test. Okay, so here in the move, we can move our Z nozzle down. I'm just take a guess here, 0.75 inches. So let's move that down. Maybe a little bit more. Okay. That should be focused enough. So we'll run it like that and we'll see if we can get this to mark. Okay, so now that our laser is somewhat focused, we're going to go ahead back into our laser tools, and now we're going to do the calibrate camera alignment. Okay, yes, we're going to do that one next. So we're going to go ahead and fit workspace. It looks like that scales it up a little bit. Our material thickness is 0.16. And then we're going to do some settings. Let's change this to 300, 20% power. Line speed can be 100, 25% power. We are going to have air assist on. And let's go ahead and frame this out to make sure our piece of cardboard is big enough. So now we can go ahead and start. Okay, so now that our engraving is complete, we're going to go ahead and go to next. And now we're going to capture the image. And you can see we can clearly see our markings there, which is good. And we can go ahead and click next. And then now we can go ahead and click on marker 1 as accurately as possible. I'm going to scroll in as far as we can. Double click. Go to marker 2, marker 3, and marker 4. Okay, that looks good. Click next, and you're done. Press the finish button below to exit. So now we should be able to go into our camera control and update our background. And there it is. Very cool. Now let's see how accurate we are with our camera calibration. I'm just going to draw a little cross here. Center these up. And then move that into the center of this existing circle that we have. So let's try engraving this out and see how accurate it is. That's a little off. We could go back and just do the whole calibration sequence again to try to get this a little bit closer. We could also just do an offset by measuring out the distance between these two spaces. So if I go here and kind of measure this distance that we're off, and then I can measure this space that's off. Let me get our units into millimeters. Okay, so we're off in the x-axis by 1.089, and we're off in the y-axis 0.645. So I'm going to go into my device settings, enable pointer offset, and then for our X we want to move 1.09, and our Y axis we want to go down minus 0.65. Am I going the right direction? Let's try. Yeah, I went the wrong way in the x-axis. So on our x-axis, I just need to reverse that. Minus. Okay, let's try that again. There we go. So now we're perfectly aligned here, so I can try it again over here. Update the overlay. Yeah, and you can see we're right on our engraving. Cool. So that's another method rather than having to go through the whole camera calibration process again, because sometimes you can't really get it perfect everywhere with these cameras, but using the offset can get you really, really close to the results that you're looking for. Now, what's obviously great about this particular laser is it has an integrated red dot, so we don't necessarily have to use the camera for alignment purposes. We can frame out our project and let the red dot laser show us where we're going to be engraving exactly. Okay, so we're configured here. Now let's try to find our ideal focal length. And for that, we're going to do a ramp test. So for our ramp test, we're going to end up taking out our honeycomb so we can have more space to work with and set up a piece of wood at an angle so we can get our ideal focal length. So I'm just using scrap material here because we're just going to end up drawing a straight line and have the engraver run across it. but we need to put it at an angle so that we can figure out where our laser head focuses to. What we just need to make sure of is that we don't hit it. So we don't want to make it too high so it hits. We want to make sure we get close to it, but not actually above it. So I can go up a little bit higher here. All right, so we're going to go ahead and update our overlay here. We can just delete this. And we can take this section out. So it goes the full length of our scrap piece here. And then we can frame this out to make sure it's going to go all the way over. And let's go ahead and check our settings, make sure we're not going to go too deep. Okay, good. Let's go ahead and do this engraving. Let's go ahead and do that again because I was a little bit off. Okay, so you can see here how it's completely out of focus and it gets really tight, really tight focus. And then you can sort of see right about here, it starts to expand back out because it's getting out of focus. So I think if we target right about here and measure that distance between where our nozzle is, we can get our ideal focal length. So I'm just gonna go ahead and move this laser head to where it was perfect, about right there. Now I'm going to get some calipers to measure that distance. It looks like about 3.4 millimeters is our perfect or ideal focus. So knowing this data is helpful because in LightBurn, we can set up some settings to use the Z-axis focus here to do some manual focusing on known thickness items. And we'll show you how you do that. Okay, so what we're going to do now is we're going to set up some macros that we can just, with a click of a button, focus our laser to a known size thickness of material. To do this, we want to kind of know what is the most common thicknesses of material that we have. And for us, 1/4 inch plywood and 1/8 inch plywood or 1/8 inch acrylic is typically what we use. But we're going to get these measurements in millimeters so that we can set some macros up. So this is just about 3 millimeters in thickness. Yep, we're going to do our first setting for 3 millimeters. All right, so what I'm going to do now is I'm going to home the machine, and then I'm going to update the camera overlay, and I can delete this. But what I want to do is I want to, now that the machine is homed, and the reason I home the machine is because in the homing process, it moves the Z-axis up to its highest setting. So that's important when doing these macros that we're going to set up. So what we're going to do is we're going to move our laser manually over to our acrylic sheet. Now I'm going to use my calipers and measure where the nozzle is at home compared to our 3 millimeter material. Okay, and that looks like it right now is exactly 30 millimeters. So we know that we want our nozzle to be 3 millimeters off of our material. So that means we need to subtract 3 millimeters from this. Of course, that's 27 millimeters. So we can set up a macro to basically move our nozzle down 27 millimeters, which will perfectly focus onto this 3 millimeter acrylic. So to configure a macro, we're going to go into our console here, and we've got some spaces that we can use. So for the first macro, I'm actually going to make it go home. So I'm going to right click on this, and I'm going to name this home/up. And this is if I want to move the nozzle up after an engraving job. So the macro that we use for this is G90 and then G0Z space 0. And that will move it up to its 0 position, which is where it is right now. So I'm gonna hit OK for that. And you can see now we have a home up button that will move it to 0. Now for this first macro, because we use 3 millimeter material a lot, we're just going to name this 3 millimeter, and we're going to go ahead and type in G90, enter G0Z minus 27, because that was our measured value to bring it down into focus. And I'm going to hit OK. So now if I hit this 3 millimeter, it should focus itself perfectly to our 3mm material. Now let's measure. Okay, that's close enough. Really cool. And now if we hit this home button, it should go back up. Nice. Very cool. Now all we have to do is pretty much the same process for our standard types of material. So let's get that measured out. All right, so for our 1/4 inch ply, which is about 6mm, so we're just gonna take 3 off of that 27, so that would be -24. So for our second macro, we're gonna put in 6mm, G90, G0Z, -24. So now when we put in our 1/4 inch material, we should be perfectly focused. Let me home the machine, start over. That looks just right. So yeah, we just need to measure our material now for our most common types, which honestly, these two are our most common types. So we're just gonna leave it as is. But if you had common thicker material like 1/2 inch ply that you normally use, you can obviously measure that in millimeters, subtract that 3mm focal length and whatever your measurement is of your material from 30, and you'll have the necessary value you need in your macro. But this works for us. Really cool. So now we can use our macros to autofocus. So right now, an integrated materials test is not something that is in the MDH software. Now that we have this configured for LightBurn and in LightBurn, we can utilize LightBurn's integrated material test to get some good settings for at least this 1/4 inch plywood. Let's try it out. So I'm going to focus it. And then I'm going to go to Laser Tools, Material Test. See what we have in default. CO2 Engrave Test. This is a very powerful laser, so I am going to do some adjustments here. I think 50 is okay. We'll just leave this as is, but for power, let's try 16% up to 60%. Okay. 0.01 millimeter. For interval looks good. This is a fill. Speed and power will be configured here. Bidirectional 0-degree scan angle. Okay, that's good. Our text. We do want to do a fill, and we're going to turn this to 50 and 35. All right, that's good. For our border, I don't know what it's going to take to cut this out. Make a best guess here. Let's say 25 millimeters per second. Never really want to exceed 70% power. I'm actually going to make this 60. Let's say 4 passes just to be safe. It'll probably cut out in 3, but let's say 4, and we'll call that good. Okay. Enable that border. Enable the text. I'm kind of curious to see what the minimum power setting is for this laser to fire, but I'm not confident that at 16% power it's actually going to fire. Let's call it 18 and just see what we get. Okay, I'm going to frame this out now to see where we need to position our material. All right, I think we're ready to start it up. Yep, super powerful. So I am really curious now as to how low we can get the power percentage at, because I like lighter engravings too. Though this is a good result, we kind of know where we are ballpark. A lot of this is like super engraved all the way through at the bottom here, which is kind of to be expected. But let's see how low we can get the power to go. Let's do another materials test, but at very, very low power. I'll tell you, I'm kind of impressed with how low we can get this CO2 laser to fire. None of our other CO2 lasers were able to fire under 15% power. And this one, we got below 5% and the laser is still firing and giving us really nice light engraving results. So you can see this compared to this would be kind of like way over here. This is like really nice engraving at very, very low power, which is just going to save our laser tube in the long run, because the higher power that you run it at for over time, it degrades that tube. But I assume if you engrave at really low power, that tube is going to last a lot longer. But this is really neat. I like that. Let's do some cutting tests. All right, so we're going to go back into our material test, and we're going to set this up to be a cut test. So we're going to use the same 1/4 inch plywood material, but what we're going to do, instead of speed and power, speed and passes, we also want to extend the width of this, because we kind of want to make sure that we're actually ramping up to the appropriate speed. So let's do, say, 20 millimeters by 5. And our speed we can actually adjust to be more realistic here. Let's go from 10 to 50. And how many passes do we want to do? Minimum pass 1, maximum pass 8. You know what, let's crank this up to 75. So 10 millimeters per second to 75 millimeters per second. Minimum pass of 1, maximum pass to 8, and then we're going to have the constant power. So let's put that at 60% power. And this is now going to be a line. And our text is still good. Let's preview this. Okay. All right, let's frame this out.
We were able to achieve some really good results with our cutting material tests, even at really high speeds. We got quite a few options of settings that we can use that left minimal charring on the back and cut cleanly all the way through. So now we're going to do a quick engraving and cut project using the best settings from our material tests. In order to cut our wood, we'll do 5 passes with a speed of 50 millimeters per second, and for engraving, we'll do a 10% power with a speed of 350 millimeters per second. Once again, a huge thank you to Monport for sending us this laser. We'll have a link to it in the description. If you're interested in this laser or any Monport machine, you can use our discount code Anonymous10 for 10% off your purchase.
I think we could have gone one less pass and that would have cut out fine, even at that speed. It's pretty incredible. The engraving is really nice and light. There's still depth to it. And again, to me, that's incredible because this is 10% power on a CO2 laser. Pretty neat.
Make sure to stay tuned for future videos where we utilize more features that come integrated into this Mega 70-watt desktop laser. Additionally, we plan on doing more projects and testing new materials with this machine soon. Anyways, thanks so much for watching this video. I hope you enjoyed it.